All right. Hello, everyone. We are live. Welcome to the next PlanetScale migration stream. Just going to check and make sure everything is working good here. How's it going today? We've got people filing in. Welcome to the stream. So we're going to hang out for a few minutes before we jump into things. Let some people file in. But today, the goal is to talk about migrations, particularly for Postgres, how to do database migrations on Postgres. We're going to talk about a couple of different techniques, show you around PlanetScale for Postgres a little bit, and answer audience questions too. Magnus says, the quality is crisp. That is the goal. So thank you, Magnus. So yeah, we'll just chat a little bit while we're waiting for people to come in, and then we'll get going. So as we go, if you have questions, drop them. Some of you are probably watching on YouTube, some on X, some on LinkedIn. So drop your questions as you have them. We'll answer things as they come up. And the plan is we'll go over and talk just a little bit about PlanetScale for Postgres, talk about the migration docs, and then we'll go into actually doing a couple of examples. We've done a few streams like this before where we've gone through migrations. This is the first one that we've done, this first migration stream since PlanetScale for Postgres went general availability a couple of weeks ago. So now it's GA. There's no wait list. You just go onto PlanetScale, you sign up, you can get access to Postgres right away. And the goal of this stream is there's probably a lot of people who are excited about it, but maybe have never done a database migration before, or maybe have never done one with a production app where you want to minimize downtime or have no downtime. And so we're going to talk about a bunch of techniques for how to do that without taking downtime, how to do it well. And there's a number of different tools and techniques. And we even at PlanetScale have some scripts to help people do these migrations. So we're going to talk all about that today. So welcome, everybody. All right. Well, while people are filing in, what I thought we could do is just talk a little bit about Postgres generally. Let me switch to a screen sharing view here. There we go. I'll scoot this over so you can see. We'll just do it like this here. So this is the database that I'm going to be using on the PlanetScale side to test out the migrations that we're doing today. So this is a really simple, it's a small database. So this is our smallest instance type, a PS10. You can, of course, get really big, really powerful metal instances, but we're just doing a really small database as an example today. But there's probably some of you here that are longtime PlanetScale users and lovers, which is awesome. But let's do like a little quick overview in case you haven't used a PlanetScale database before, or maybe you have, but you're still kind of new to just the interface and kind of how you work with a PlanetScale database. So there's a number of ways to interact with your database. Some people prefer to interact almost entirely via the API. We have a pretty rich API and command line interface where you can interact with and control and resize your database. So you can go and look at the docs for those. We have on our docs website our API reference and our command line reference over here. Zoom in a little bit on those. But in terms of the UI, this is your dashboard. And what you're going to see when you create a new database after it's spun up and all ready is you have 3 nodes. So by default, we always give you a primary and 2 replicas, and we spread these across availability zones. And we do this so that you have high availability, right? If there's ever an issue with one server, sometimes there's issues with servers that are totally outside of your control. We can do failovers and keep your database up and running and happy, even if there's like issues in AWS or issues in GCP. So that's kind of what your overview is here. You can see a little bit of stats on connections and your CPU and memory usage, your storage usage. So we give you a nice quick overview. And also, if you've just recently created your database, we'll give you some links to different instructions for how to do migrations. And this is what we're going to be talking about today. We have some provider-specific ones. You can use AWS DMS for this, a bunch of different tools that you can use. So there's a bunch more people in here than there were 5 minutes ago. So I'm just going to welcome everybody to the stream. And if you have any questions as I'm going through about PlanetScale, about Postgres, about migrations, drop them in the chat. And I'll take little breaks here and there to answer audience questions. I need to just change one setting here, and then we can keep going. All right. So a few features that I want to point out. There's a bunch of good stuff here in the PlanetScale UI. We're not going to have time to talk about everything. But one of the things that I really like is the metrics page, which currently this doesn't look super interesting. And in part, that's because this is just a database that we're using to try out a migration. I don't have a good example database right now. Sometimes I have ones where we can show off a lot of cool metrics and features. But what you get in here is a really detailed view of kind of the resource usage of what's going on in your cluster, right? So right now I'm not using a whole lot of CPU. It's below 10%, not a lot of my RAM. But you can see your IOPS, how much storage your database is using, a bunch of information about connection counts to your database, your ingress and egress. So right now there's not a lot going on here. But this is where you would go to look at, hey, is my CPU being pushed too hard, and do I need to upgrade my server? What's my RAM usage like? How many connections do I have, right? Because we let you configure connection limits, and so you can kind of look in here to get useful information about all that kind of stuff. And that goes along with, especially with Postgres, one of our goals was to give users a lot of control, because what you're getting is real Postgres, right? This isn't some Postgres API on top of some other storage layer or something. This is real Postgres. And so over in cluster configuration, this is where you can do things like if you want to change the size of your cluster or switch over to PlanetScale Metal, you can do that in here. It's where you can control extensions. We give you ability to kind of customize things with your storage. So if you need to enable or disable auto scaling or increase your IOPS, if your IO demands are increasing, you can do all those kind of things in here. But the main thing I wanted to show was parameters. So we give you a lot of ability to control both PG Bouncer, which we give you PG Bouncer by default as well as built-in Postgres configuration options. A lot of the common ones that people like to configure. So for example, in Postgres, a common thing that people want to change is, well, maybe I should we can use our search feature instead. Like the shared buffers, right? Your shared buffers or your wall buffers, we give you the ability to change this configuration option. So I could go in here and I could increase the size of this, and I would queue it. And it does warn me that this is going to require a restart. So if I apply this change, it's actually going to restart my database. I'm not going to do this right now, but a lot of control over configuring connections and memory usage and a lot of different stuff for your database. And the reason why this shared buffers value is so low is because this is just a really small database with only, I think, 1 GB of RAM. So there's that. And then lastly, the other feature I want to show is insights. So let's look at, again, there's not really an interesting load on my database right now because we're going to start doing stuff with this once we begin the migration. But over here, I can see a graph of my P50 and P99, essentially a lot of performance information about my database. And this is where a lot of people go to investigate if they're having performance issues. So right here, you can see kind of a per query breakdown of all the queries executing on my database. Most of these are queries that have to do with data loading. So yesterday evening was running some tests, right, to make sure that this stream would go well in loading data and doing data migrations. So most of what you see in here are a couple of select statements and then a lot of things for creating tables, altering tables, loading data, copying data. But when you have your actual query workload going in here, you'll get really detailed stats on all kinds of stuff. So like how many times every query executed. You can look at things like what % of the CPU time is this query using, and I could sort by, hey, I want to see what queries are using the most CPU on my server, and then I could see very clearly like here this, and then if that is a problem, I could go and address that issue, right, and do some query optimization or something over there. So these are all the awesome features that you get, right, if you choose to use PlanetScale, high availability, especially if you're on PlanetScale Metal, like really, really great IO performance. In fact, we just published a blog comparing the performance of Postgres 17 versus 18, which just recently came out. And there's a lot of cool improvements in Postgres 18, but also one of the clear takeaways is we ran it on a bunch of different common cloud server configurations, many of which use EBS, which we let you use as well. But if you use local NVMEs like we use on Metal, you really get a lot more performance with the same amount of CPU and RAM, which is really nice. So these are kind of some of the main features I want to highlight. Again, there's lots of things. We give you really detailed views into your logs. We do automated backups, and you can do point-in-time restores. You can do branching, lots of really cool things. You can do role management all through the UI here. So again, I'll remind people, we've got a bunch more people that have come in since I last talked. So pretty soon we're going to jump into talking about migrations specifically. So if you have any questions either about Postgres in general or certain challenges maybe that you're facing with doing migrations from one Postgres host to another, drop those comments in the chat, or really anything database related. I'll answer any database questions if I know the answer. So let's go and look at the docs, because if you are planning to migrate to PlanetScale, the place that I recommend that you go to kind of as a starting point is we have a bunch of docs that are a good place to start for getting your feet wet with migrations. And we cover a bunch of the different techniques that are going to probably satisfy the majority of customers. So you come in here, we also do Vitesse MySQL powered databases. So if you need MySQL, you would go over to the Vitesse docs, and we have migration instructions for those as well. But if we're doing Postgres, we go over to the Postgres docs. We have a bunch of things specific to our Postgres product in here. And then you could go down to the imports tab. Oh, you can't see that very well. So I'll just hide my face just for a second here so we can see the docs a little better. So we go over to Postgres, and then in this import section, there's a bunch of different things, right? There's an overview, and we have some instructions that are sort of very generic, right? Like dumping and restore. So there's a tool called pgdump, which allows you to basically take a full copy of your database out of whatever your source is and then restore that to your target, like PlanetScale. So we have kind of general instructions for how to do that. Very generally, how to do logical replication streaming as a part of your migration, how to use Amazon DMS, which is a tool that Amazon provides to help make migrations go smoother. But we also have a few specific provider guides, and we'll add more of these over time. But for now, we have Supabase, Neon, Aurora, and then Aurora via DMS instructions. And if you don't see your particular provider here, reach out to us, right? And like we said, we're going to be working on more of these guides going forward. But the example I'm going to use today is I already have a Aurora database set up in one of my AWS accounts. And so we're going to kind of use a lot of the same techniques from these instructions here for what we're talking about today. So we'll click over there. Let me resize this just to make sure I'm not cutting any of it off. Okay. So these are the instructions for the most part that we're going to follow today. And there's a few things before we really jump into the details that we'll talk about. So one thing is we're going to look at two specific examples and walk through them. One is the dump and restore technique, which that one is really good because it's very simple and pretty easy to do, but that is one that requires downtime. So if you're dumping a 50 gigabyte database and then restoring that to PlanetScale, how long that takes depends on like how much compute and IO resources you have in your server, but that could take, let's say, a half hour or an hour of downtime to pull down the 50 gigabytes and then restore that to a new database, right? So some people are okay with that. Some people are, hey, in the middle of the night, we'll take our app down for 30 minutes or an hour to do a migration. But for a lot of people, that's kind of an unacceptable amount of downtime, right? And very understandably. So we have a couple of options for that as well. One is what this guide talks about, using logical replication, which doesn't quite totally eliminate downtime, but the downtime is measured more on the order of seconds rather than on the order of hours or half an hour. And then another thing too is these guides kind of provide detailed step-by-steps for people who like to sort of be involved in all steps of the process. We also have a set of migration guides, or not migration guides, migration scripts in addition to the guides that can help you automate some of this stuff. So these scripts, some of them are doing basically the same things that the guides talk about. They just automate some of it. And then some of them do a couple of extra things that help minimize downtime. But these are a really nice option if you are willing to come here, kind of read through the README, and if you're comfortable executing these scripts, on your source database and then going into PlanetScale, these are a great option that sort of handle some of the complexities for you. So I'd recommend looking at these as well. But we're going to look through this one. And initially, we change something over here. So initially what we need to do is make sure we have set up our PlanetScale database correctly. And I've already taken care of most of this stuff, but we'll just walk through it. So you create a PlanetScale account, and maybe you already have your database ready to migrate, or maybe you still need to create one. But you go through and we kind of walk you through the creation steps and how to choose the right database. And once you have that created, you're going to need to get a connection string. And we have a really nice UI for creating roles and managing roles with different levels of permissions. So we have some recommendations for what to use here, but you can modify that if your needs are different. But basically you need the connection string, username, password, and our recommendation is like during this process, you would store these, in some kind of local environment variables or something, and keep them secure, and then use these connections for your migration. And then we also have a few recommendations that aren't required, but for example, if you have kind of a really large data set that you're going to transfer, one of the things we recommend doing is increasing your max worker processes so that there's more background worker processes to do migration stuff. But since this is a pretty small database, it's not really necessary to do that. And then the other thing we recommend is, although we do have auto-scaling disks, if you're on an EBS or network attached storage, we do recommend that if you know the size of your database that you're importing, that ahead of time you configure the disk size, because there are some limits to auto-scaling. It can only change sizes every 6 hours or so. And so, for example, if I think the number we use in here is we recommend whatever size your source database is, actually go 150% of the size on PlanetScale. And a part of this is because when you do a migration, because of the way Postgres works, it can sometimes introduce bloat on disk. And so if you have a 300 gigabyte database, you may want to size it to 500 gigabytes on PlanetScale. Or if you're doing metal, you want to make sure you just have a disk that has some headroom in it for your migration. So, and then I've already done most of that work. I already have my connection strings. In fact, over here, I did using my PlanetScale connections. I'm already connected just in pSQL over here to this database. We can see I don't have any tables in here right now, but we're going to migrate some in with the example that we're going through. And then you prepare your Aurora database. And again, I've done a lot of this stuff, but this presumably, right, like if you're coming from Aurora, you already have that database. It's already probably serving production traffic right now, right? So this is something that, you need to take care of, because you don't want it to negatively impact the stuff that it's handling right now. But you have that database, and then there's just a few things you need to make sure and configure. And the big one is you need to make sure that logical replication is enabled if you're going to follow these instructions. Because for most databases, we recommend using one of the techniques that requires logical replication. So to do that, you would either create a new parameter group or update your existing parameter group. This is how you configure Postgres instances in Aurora. And then we have a couple recommendations for you. Need to make sure you change this setting and this setting, your shared preload libraries, and make sure you enable logical replication. And then you can confirm that all those settings have changed by doing your show wall level over on your Aurora database. And so I also have my Aurora database. I'm connected to that right here. You can see that I'm just using the command line connected into Aurora. And I can check and make sure that my wall level is logical. Make that font a little bigger. So this database is properly configured. Again, I already have my connection, username, password, host, all configured here in these environment variables. And this database has 10 tables in it. For those of you that have done benchmarking before, you might recognize these as like Sysbench has an OLTP series of benchmarks, and these are ones that come from that. So we've already got that, and let me just show you the counts of all of the tables here. I've got a command I'm going to bring over just to make it simple. So we got like, 1,100 or so rows in each of these tables. And right now there's actually no traffic inserting rows, but I'll also show you later what it looks like when there's traffic adding rows. All right, so let me check this. Cool. So as we go, drop questions if you have them, but we'll keep chugging along here. And I told you I would show you 2 ways of doing this. So the first way we're going to do is actually the simpler way that I talked about before. Like I said, you can just do a dump where you dump the entire contents of your database and restore that to PlanetScale, and then switch your traffic to PlanetScale and kind of do it all in one sort of atomic operation. But during that window of time, you don't want any traffic going to your old database because you don't want new rows to get inserted and those to get lost when you transfer over. So this is what you would do if you're willing to take a little bit of downtime, or if your database is small enough. Like this is a really small one. This one's just like 10 megabytes or something, 20 megabytes. So this one is small enough where I can do that whole dump and restore in just like a minute or 2. So it would be only a very, very minimal amount of downtime. But basically the way that you do this, and I'll bring a command over here, zoom in here, let's clear this, is you're first going to run this pg dump command. Make that even a little bit bigger. So pg dump is a tool that comes with Postgres that allows you to dump out either all of your data or all of your schema, or you can do everything together. There's a bunch of options for it. So what I'm going to do is have it essentially take a snapshot of my entire Aurora database and put it in this file called data.sql. And again, because this is a pretty small database, and this is even running from my local laptop to an Aurora instance in US East 1. So there's also a pretty large amount of network latency. Would be even faster if you were on like another instance in AWS. But we dumped that entire thing. Now I have this file here. Can do like its size. It's pretty small. It's 2.1 megabytes for that entire SQL file, right? And that contains all of my schema, all of my data. And then what I would do is, if I already have my PlanetScale database ready, and remember over here, I'll do a, let's just scroll this up so you can kind of see it above my head there. If I do DT here, there's no tables and no relations, no data. And so then if I run this, which is now a pSQL command to take everything in data.sql and load it into, these are the variables that have my Postgres PlanetScale database config in it. So I can load that in there. It's creating the tables, it's creating the sequences, it's copying the data for all those tables that have 1,100 rows, creating a couple indexes, and in a matter of 10 or 20 seconds, even with kind of the high latency of being far away, it was able to copy all of those in there. And then let's also look at, make sure all the row counts match up, right? So all the row counts match from one to another. And then this would be the point in time where you could then say, okay, I've gotten all my data copied over. If you wanted to, you could do extra steps to validate that the data is correct and didn't get corrupted. And then in whatever applications you have that are connecting to your database, you just switch that traffic from your old Aurora credentials to your new PlanetScale credentials, and then you are migrated. So as you can probably tell, that's a pretty easy way of doing it, but it's, has the downside, right? Of if this were a large database, if this were 100 gigabytes, that would take a lot longer than, 60 seconds. So that is using the dump and restore technique. Over here. So if there's any questions on that, you can drop them in there. And then pretty soon we'll talk about doing this with logical replication, which requires a few extra steps, but is a little bit of a smoother process in terms of the switching over and not needing to really take down time for it. All right. Okay. Well, what I'm going to do is I'll probably drop all of the data out of this one because we're going to use the same database for the example again. So let's just delete all of these tables. Ooh, what happened there? Oh, I tried to copy this command. That didn't work right. Let's do that again. Okay. So now we don't have any of those tables in PlanetScale anymore. We still do over here. Okay, so the other technique is more of what the kind of moving on from this point where we got in these instructions before, right? So the first step, once you have all of your databases prepped and you have logical replication enabled on both, is actually to do a step of copying the schema from your source to your target. So a key thing to keep in mind if you're using logical replication is during the process of your migration, you shouldn't do any schema changes. So this, more or less means you're probably going to have to do a brief code freeze in terms of features on your application, because most features require, adding or removing or modifying a column. So for however long it takes, right? So these migrations can be a couple of hours and you're done. Some people like to have them go for days or even multiple weeks, because not necessarily that the data copying just takes that long, but you might start the migration. Migrating the data might just take a couple of hours. But then once you have it migrating, what it's going to do is Aurora, anytime a new insert or update or delete happens over there, it's going to mirror that over to PlanetScale. So what people like is you kind of are running these two databases in parallel, and you can, before officially switching over to PlanetScale, you can do some performance testing, do some validation to make sure all the data copied over correctly. And then once you know for sure that you're ready after a couple of days or a week of testing, then you can do the cutover, right? So during that time, you don't make schema changes, but we do need to do an initial copy of the schema because the logical replication is not going to do that for us. So we have the example commands in here, right? Like, so you store your Aurora credentials in here, and then we have commands for doing those. And I have those over here that I can just grab. So over here, again, this is just running on my local machine. I'm going to run a similar pgdump command from earlier, but ask it to only give me the schema. And we're going to put that in schema.sql. Should go pretty fast. It's just grabbing a couple tables. And there we go. So now that is all in that file here. We'll look, probably won't be able to. So it's pretty verbose, right? Because it even saves like default encodings and transaction timeouts and all this stuff. But it has the create table statements, the create sequence statements for all of my tables, all of my sequences, all of my indexes that I've added to my tables, but none of the data itself is captured in here. So we close out of this, and then we run and load that schema.sql into my PlanetScale database. So it's just going to take a couple seconds for it to do all of those DDL operations. And now back over in my PlanetScale terminal, you can see that I have all of those 10 example tables, but let's do the counts. All of the row counts are 0. So no data was copied this time. Okay. So that's the first step here, is get your schema copied over. And then from this point on, don't make any schema changes until you're ready to actually do the cutover. And then we need to actually set up this logical replication connection between the two. And so that requires running a command on both your Aurora database as well as on your PlanetScale one. So let me toggle over to Aurora here. Let me actually change. I kind of want the PlanetScale database and the Aurora database to be one on top of the other here. So move these around a little. And we'll just move this, my little utility one up here. Okay, so here's Aurora. Here's PlanetScale. And what I'm going to run over here is a command to create a publication. And you give it a name. And you can be more selective with logical replication. You might say, I only want to do a subset of my database, a subset of my tables. But here I'm saying, let's just do it for all of my tables. So we'll go ahead and create this. Created the publication. So now I'm ready to subscribe to this publication, which will allow me to bring all of my tables over from here into my new desired target. So then get the create publication. We have instructions for what do you do if you want to do this for only one schema or a subset of your tables. And then this command here is kind of the key for getting the PlanetScale side working. So I think I already have this elsewhere over here. So I'm going to copy this one. So this is actually a command that I'm going to just run from my local machine, but it's going to connect to PlanetScale. And before I execute it, let's talk about it. So we're running a psql command. And this is really just to connect to PlanetScale so that I can then run this SQL query here. And what this one is doing is it's creating a subscription. Let me resize this so you can see right. Creates a subscription to subscribe to that publication that we just made. And I give it the credentials. And I'm running it from here so that I can use these environment variables, generate the query, and then send it off to PlanetScale. And then a key sort of important thing that I've added here is with copy data equals true. And what this does is it not only replicates new changes that come into Aurora, right? If a new row gets inserted into Aurora 5 minutes from now, it'll send that over to PlanetScale to be replicated there. But this also does an initial data copy. So all existing rows, all existing data gets brought over to PlanetScale. And so you can do those as two separate steps, but here I'm doing them all together. So I would run this, and it created a replication slot on the publisher, and it created the subscription. And so now data can actually begin flowing, the replication from Aurora to PlanetScale. So I'll move this back over here and we'll look at what that looks like. Okay, so if we again look at row counts, this is PlanetScale. Some of the tables have their rows, right? Like basically it's in process right now of sending doing the initial data copy, right? But this is all happening while the Aurora database is still up. We didn't have to stop traffic to Aurora. Aurora can still be serving queries, getting new inserts, getting new updates, getting new deletes. So there's no downtime at this point. It's just doing basically a background job of copying everything over to PlanetScale. And so now my row counts, not doing any inserts yet, but my row counts match between the two. And then what we'll do, let me find my example command here. Yeah, so I have a command that I can run, which will actually cause some inserts to go into this database. And it's a sysbench command because that's how I generated the sample database. So I'm going to run this just so that we get rows inserting into Aurora. And what we'll see, if I run this again, right, like this one's now at 1200. Some of them have reached over 1200. We do this. Now all of them are over, or most of them are over 1200. So we can see that rows are getting inserted into all of these tables, right? They're growing in size. But because I have that logical replication stream set up between the two databases, those new rows that are getting added to Aurora get inserted, saved in Aurora, and then also passed along over the network to PlanetScale and essentially mirrored into PlanetScale, right? So again, no downtime is happening yet. This is simulating, right, traffic from your users still going to Aurora, and all the while it's mirroring things over into PlanetScale, right? So this is the point where pretty soon we're going to be able to do a cutover. There's one or two more things to do, but this would be the point in time where if you wanted to, do performance testing, right? You could go in PlanetScale because it's essentially a copy of what you had in Aurora, and you could start testing your queries, making sure performance is good, making sure all the data is there before you kind of make that final decision to like, let's cut over the traffic to our new database. Okay, so rows are getting inserted. I'll pause the whole row insertion thing for now, but just know that, right, like rows can be being inserted while this is all happening. And now that it's kind of paused and settled, we can see that the row counts match up over here. And I also have a recommendation there in Postgres. There are log sequence numbers. Hi, Daddy. Go on out. Hold on one second here. Hold on one moment. Okay. I had a little guest coming into the room. Okay. Always fun to have a kid knocking on your door when you're doing a live stream, right? Okay, so let's go look over here back at our databases. All right. So we can have this traffic going. And then what we're going to do is a few other steps to make sure that we're fully in sync. And like I was saying, that one of the recommendations is you can look at your log sequence number, which essentially tracks like where in your log kind of identifiers for like how far your write ahead log is tracking all of the changes that happen in your database. And so if you see that the log sequence number matches between Aurora and between PlanetScale or whatever you're coming from, then you can kind of have a higher degree of confidence that your database on Postgres is caught up to the same state as Aurora, because there can be a little bit of what's called replication lag when you do this. So it's good to double check that, but there's one other important thing to do that you want to be very careful to make sure you do this before a cutover actually happens. And that is handling sequences. So in Postgres, when you do things like an auto incrementing counter, for example, a big int ID that's auto incrementing on one of your tables, what you have to, it works a little different than, let's say you're used to MySQL, where there's these special things called sequences that keep track of these auto incrementing sequence, what's the next number in the sequence value. And so these, although the creation of the sequence does copy over when we copied the schema, it does not sync the next values between them, which if you don't account for this when you do the migration, when you cut over your traffic, you can start to see a bunch of errors because you can't generate new IDs because the ID sequences are out of sync and are not set at the correct values. So what we'll do to solve this, and you can run a query like this to just see all of the sequences that you have. So for each of my tables, basically, this is a simple example where every one of my tables just has an auto incrementing like integer ID, and I have a sequence for each one. And I can see that these are the next values for that. But over here on PlanetScale, you can see that the next values didn't get passed in. So this is what would have caused problems if right now I decided to switch traffic. So we got to make sure that those are set to, at the very least, the same value. But actually what we're going to do, and what I generally recommend, is when you set your sequences on PlanetScale, you set them further ahead of what is on Aurora, enough so that you have time to do the flip over and the migration, where you don't exceed those values in your like auto incrementing IDs. And this might leave, or this likely will leave, a little gap in your IDs, but that's worth it to make sure the migration goes smooth. So what you would do is we have a little sort of utility query here that can be kind of helpful. And what this does is this generates a set of select statements, which will cause, if I run these over on PlanetScale, it will set my sequences not only to the correct value, but it will advance them by 10,000. And you can change this value to make sure that we have plenty of buffer for my IDs over in the new table. So I'm going to go ahead and run all of those over here. And now when I do my counts, we can see that I have next values that are incremented well in advance. And so even if I get some additional traffic to Aurora and those numbers keep advancing because there's new rows getting inserted, I have enough buffer here to where that won't be a problem, as long as I do my migration quickly enough, right? So you got to use your best judgment on how far to advance those sequences. And if you're using the scripts, we actually have, as a part of the scripts, one of the scripts can sort of auto figure out, like, here's how far in advance you should set your sequences to. And you can use that script to help you not have to think as much about this. But regardless, whether you use the scripts or manually, you still have to do that. And then at that point, it is safe to cut over once you have confirmed that everything is kind of as you want it to be. Now, I don't know for sure if looking at the wall LSNs is going to work here. And in part, that's because the write-ahead log changes on more than just data inserts. So it changes when there's vacuuming processes and things like that. So in this case, they're not actually fully in sync. And this is probably because over on Aurora, there's some additional, whatever it is, maybe auto vacuuming processes, something like that that's going on that's causing the wall to continue to change. And so the data really is in sync here, but in this case, it's a little bit harder to detect that using the LSN. But on some providers, that's going to be easy to just look at both of those and say, great, they're in sync. Like you can have some higher confidence there. Okay, so we've got a question. So let me read through this. It looks like there's a couple of parts. So there's a current database on a container, a Docker container in a VPS. It backs up to S3, okay. Does PlanetScale have cold start issues? So no, we don't. And that's because we don't do like scale to zero, right? There's some other companies that do scale to zero where they essentially shut your database off. And then if there's no traffic to it for a couple days or whatever it is, and then turns back on when they're doing a cold start, we don't do that. You pay for a certain amount of resources, and then we give you those database resources all the time. So you don't have to worry about cold start issues. And then vendor lock-in. If you decide to self-host the database again in the future, how difficult is it to migrate away? Are there lock-in concerns to be aware of? Not really. So this is real Postgres, and some vendors make the lock-in story kind of harder because they do things like either disallow, or at least by default, they disable logical replication, which is one of the main tools that you can use to, migrate data like I'm talking about here. So logical replication is enabled by default. And just like, if you wanted to, you could use the same set of steps I'm showing you, but in reverse, if you're like, hey, I don't like vendor lock-in, right? Now I believe you're going to be pretty happy at PlanetScale, but like we want to give you the full power of Postgres, from the performance characteristics to tuning it via cluster configuration to doing various logical replication. And the logical replication story isn't just for migrations. It's also for things like you may want to use logical replication to export your data to some kind of external analytics tool or something, right? So you can use logical replication slots for those reasons. So we give you the full power of Postgres. Those are good questions, though. All right. So basically at this point, right, once you have done whatever validation you needed, right, and again, right now I'll start up this script again that sent traffic between the two. I can still have Aurora with no downtime handling my traffic all while all of this stuff is going on, while I'm updating slots and all of this stuff. Let me do my counting. So there's the counts there, right? And I can be making sure that those are my ID values, right? So you can be making sure that the data is copied over correctly. And then once you're confident that you are ready to switch over, this is where kind of the coordination is required. Because what you would do is you would very briefly stop traffic to your old database, because while you're switching to PlanetScale, you wouldn't want rows to sneak in to Aurora that sort of get double written or don't get written to PlanetScale, right? You want to avoid any of those kind of things. So you'd have a period where you stop the traffic to Aurora and then ensure that, hey, all the row counts, all of the data has synced up however you want to validate your data. And then in your app servers and whatever other things rely on connecting to your Postgres database, you update your credentials, you have it point at PlanetScale instead, and you deploy that. And now you're using PlanetScale as your primary. And you would just be writing to the PlanetScale database, and it's not going to reverse copy all of the writes to Aurora. That's why you want to be pretty confident that you're ready to do the migration. And then once that happens, right, there may be a very brief period of sort of unavailability of your app during that time, because you pause writes and then you start them back up again on PlanetScale once you know that everything is copied. But generally, that's a very short period of time. And then you're migrated over to PlanetScale, right? And we can see if I keep doing more counts, right? Right now that's still going. So at some point you would do the pause, you would ensure data is copied, and then do the switch. So those are, or that set of steps is logical replication. As you saw, more steps there to keep track of and stuff to configure in your source database, but we can do it with a very, very minimal amount of having to take your app down or anything like that. So again, I'll point at I still have the tab open here. The migration scripts allow you to do a very similar thing to that, but automates some of those steps of updating sequences and creating the replication slots and those kind of things. And there's also, we have a couple of other options in the scripts. Like we have one option where you can actually do it with really much more closer to truly no downtime. It's a little more complicated because it actually requires you to create 2 PlanetScale databases. One is the one you're going to keep. One is a temporary database that you use as a proxy between your source and your target. And that is your proxy that while you're doing the cutover, you can still make connections to that database. So we have a couple other fancy features over in the scripts here. So take a look at those for if you want to use those features or if you just like automating things a little bit more. Really good resource there. And then there is another tool too. There are some people, especially if you're really in the AWS ecosystem, you might be used to using AWS tools for these kinds of things. And Amazon has a tool that's pretty good called DMS, which we have both general instructions for up here. Let me scoot this over. So we have some general instructions for DMS, and we also have a specific Aurora guide as well because it's all Amazon. And so if you want to use that to manage your migration, you follow these instructions and use some of our automation around getting DMS set up. We got a lot of really detailed instructions here. So a bunch of ways to migrate your database. And at this point, we have successfully done so in 2 different ways on this stream. So I'll hang out a little bit longer if there's any remaining questions on migrations, logical replication, PlanetScale in general, Postgres in general. Talk through those. It's the stuff that I love to talk about all day. So I don't mind hanging around and answering questions. We'll go in here and look too. It's probably not a ton of traffic, but we can see, I'll look at my traffic in the past hour. We had a couple of spikes. Normally these graphs look a lot more interesting when you have real production traffic, but we can see that there was a bunch of, we had our create table statements, right? But then quite a few copies, right, for copying our data over. So these are all the queries that happened while we were doing this migration demo. All right. Well, I think that is it. Had a lot of people join, so I hope you all learned a lot. Weren't a lot of questions, but I see there's a lot of people that have joined the video. So I hope you all learned stuff. If you have any questions or if you're doing a migration and you get stuck on something, reach out to PlanetScale support, planetscale.com/contact. You can also email postgres@planetscale.com. There's lots of ways to get a hold of us, and myself and our solutions engineers and our support staff are always happy to help answer those questions and get you unblocked. So thanks for joining the stream, everybody. Reach out, and you all have a great rest of your day.